Welcome to Unit 3, Lesson 2, Graphs of Rational Functions, Part 1. So we're going to explore graphs and equations of rational functions. Okay, and one thing we have to know about this unit is that rational, when we see the word rational, you have to think fraction. When you hear the word rational, think fraction, or it can be expressed as a fraction. Okay, now for this biking problem, what we have to know is Karan's aunt plans to bike 10 miles. Okay, so this is a distance. Obviously, when she's riding, she has some type of speed, and we need to know how to relate speed, distance, and time. So these three go together. So speed equals distance, that's a C, that's a E, over time. Time equals distance over speed. And distance equals time times speed. Okay, now, this is called a family of equations. You have the same variables in different places. So whatever you're looking for goes on the left. You have to be given the other two. Another way to look at this is to put it in a circle or a triangle. So distance is speed times time, where this is multiply. And whenever you see a horizontal line between two numbers or two variables, or a variable and a number, this always means divide. Okay, so now that we got this down, now we can start to look at this problem. Okay, Karan's aunt plans to bike 10 miles. Okay, so I put my distance, speed, and time circle over here. So basically, put your finger over the one you're looking for and you know what to do with the other two. So how long will it take if she bikes at an average rate of 8 miles an hour? So how long will it take? So that means we're looking for time. So time is distance over the speed. So our distance is 10, our speed is 8, and we get 1.25. And then time is measured in hours. So that's our time, hours. Now, again, how long will it take if she bikes at an average rate of 4 miles per hour? How long is time? Distance over speed. Distance is 10, and speed is R. So it's going to take 10 over R hours. Now, our time is in hours. Now let's look at number 3. Karan's aunt wants to join him, but only has 45 minutes. All right, what will their average rate be? Our average rate is miles per hour, so we need to change 45 minutes into hours. So what we have to do is 45 minutes, 1 hour is 60 minutes. We must get the units to cancel out. Unit conversion. So if minutes is on the bottom, that means we have to divide by 60 to get the hours. And so that gives us 45 over 60, which is 3 over 4, which is 0.75 hours. So 45 minutes is not a full hour. So we had to convert it to hours. So now, what will the average rate be? Rate is speed. You can interchange rate for speed. So speed is distance over time. Our distance is 10 divided by 0.75 gives you 13.3 repeating, which is a third. And since this is a speed, this is miles per hour, or mph. Because we're given units in our problem, we must write units in our answer. And then finally, what will their average rate be if they have t hours? Again, we have speed is distance over time. Our distance is 10. Our time is t, miles per hour. Okay, now we're biking 10 miles. Karan plans to bike 10 miles. Or Kieran. I keep saying Karan. Kieran plans to bike 10 miles. Write an equation that gives him his time as a function of his rate in miles per hour. Okay, time. Time is distance 10 over r. Distance divided by the speed gives you time. All right, now graph y equals t of r. So now in your calculator, you're going to hit y equals. You're going to hit 10 divided by x. The x button is next to the green button called alpha. And then you're going to graph it. And when you hit graph, your graph is going to look like this. And we're only going to worry about the positive side. We're not going to worry about the negative. So don't worry about the negative. Don't worry about this just yet. Okay. So R is our input. So this is speed right here. And our output is time. Okay. And the slope of the line is distance. So as you can see, the graph approaches the x and the y axis. And these have a new word, our new word for the day. These are called asymptotes. Asymptotes. An asymptote is a line that a graph or curve approaches but never touches. So it never touches the line. So let me get this out of here because we ignored the negative side because we don't deal with negative speed. Okay, so these lines, that y-axis and the x-axis are asymptotes. This graph approaches the y-axis. It never touches it. It approaches the x-axis, but it never touches it. Okay, so now that you have your function in there, what you're going to come back now and do is second graph. Now we're going to look at the table of values. So it says t of 8. 8 is the input. That means when x equals 8, what does y equal? And if you scroll down to 8, you will see that y equals 1.25. And that's the same thing we got on the previous page. Now, what is the meaning of t equals 0? So if you scroll up to 0, when x equals 0, y equals error. And why is that? We cannot divide by 0. Why? Because if you do 1 over x and divide by 0, this is what's going to happen. As you approach 0 from the positive side, you go this way, the end of the graph goes to positive infinity. As you approach x from the negative, let's do this in a different color. As you approach x from the negative side, the end of the graph approaches negative infinity. So because they go to two different infinities, we say dividing by 0 does not exist. And that's a main concept in this lesson, in this unit, this whole unit, not just a lesson. So as r gets closer to 0, as r goes closer to 0, the speed, because speed is on the x-axis, increases. Let's erase that and start over. Increases greatly. So if you look at the numbers, At 8, it was 1.25. At 7, it was like 1.4 something. At 6, it was like 1 point, I don't know, 5 something. At 5, 10 divided by 5 is 2. At 4, it was like 2.5. At 3, 10 divided by 3 is 3 and a third. 3.3 repeating. 10 divided by 2 is 5. 1, when x was 1, it was 10. So the speed is climbing very quickly. And as you get down to your decimals, it's going to climb even faster. Okay, now this is part of the lesson summary. What I wanted you guys to do today was to highlight the first sentence in the paragraph. When you read that, basically, what it is saying is that a vertical asymptote is where the denominator equals 0, and that's an important thing. So you will not see dashed lines on a calculator. We got to figure out how to put them in. But on the papers, not the papers, but the things you see online, you will see a dashed line representing the vertical asymptote, but you will not see them on the calculator. You will see the graph do different things at the ends. So you'll see the graph do something like that, but you will never see the dotted lines that would occur on the lessons. And that's all for this lesson. Thank you for watching this video.